Once your new solar system has arrived, it's important to inspect all items for possible damage due to shipping. The system installers need to open up the eSun solar system packages to confirm that all parts are present as outlined in the installation manual. Ensure that all necessary and required tools are available on the job site as listed in the installation manual. Ensure that the site evaluation is carefully reviewed for sun optimization and shading using one of the tools available for shade analysis. Whenever working on areas more than 6 feet above ground level or on a steepness with more than a 3/12 pitch, OSHA requires that all workers are protected with an OSHA-approved fall harness and lanyard attached to a secure anchor point from above. The solar installer first draws out a diagram of the array with the measurements taking into account the solar module width plus the space for the solar module hardware. The installer then first marks on the roof the outline of the total solar array. The installer then measures and marks the outlines of the individual rows. The roof layout shown in this video is a 6/6 pitch with 6 solar modules on top and 6 solar modules on the bottom. The array may be installed in several different configurations to meet the customer's roof layout requirements. The installer then marks where the rails will mount to the solar modules on the roof as per instructions in the manual. Using a chalk line, the installer then marks horizontally across the roof where the penetrations for the rails will be attached, using the mounting L-feet. The installer needs to reference the overhang and spans in between the mounting L-feet, and starting at one side of the array, find a rack on the horizontal chalk line to mount the first mounting L-foot that is within the specified overhang limit. The installer will then go and mark the rest of the solar array layout, starting at the bottom of the array where the first station for the mounting L-feet will be attached. The installer would go to the top row and find that same rafter to attach the top L-foot as was done on the bottom row. It is best to lift the shingles when using a pilot bit to find the hole for the L-feet so as not to compromise the integrity of the roof. The idea is to find the center of the rafter and drill the pilot hole for the L-feet. After drilling the pilot hole, the installer will need to apply sealant. A minimum 50-year rated roof sealant such as Sikaflex is recommended. Then install the lag bolt with mounting L-foot attachment. When applying the lag bolt to the mounting L-foot on the roof, tighten lag bolt until the foot is completely secure to the roof. At that point, you should see some of the sealant or mastic squeezing out from between the mounting L-foot and the roof. The installer will then loosely attach the rails to L-feet. Note, rail splices need to be bolted together using the self-tapping screws that are included in the kit. Once the rails are installed on the roof, the installer will start from the ends. Slide the 3/8 inch bolt into the rail to a point that aligns with each of the mounting L-feet. the solar array is square by laying it against the ends. The installer can then use the straight edge across the top to ensure all of the rails are on the same plane. After the rails are installed, decide the best location to mount the inverter, preferably near the existing meter, main, or sub-panel. This will allow for the most efficient installation of EMT conduit from the electrical panel to the inverter, then up through the roof to a weatherproof junction box, preferably located under the solar array. Note, all penetrations through the roof should be flashed using approved flashing. If required, it is acceptable to run EMT conduit in the attic and come through the roof. The inverter should be mounted securely to the wall according to the inverter's manufacturer's specifications and clearances. Short runs from the solar array to the inverter junction box are typically run using half-inch EMT conduit and then number 12 THHN. For longer runs, see the manual for details. DC wiring is then run using USE number 2 cable from the positive and negative ends of each string of the solar array. Additionally, the rails are then bonded with number 10 bare copper using the weave lugs supplied with the kit. All splices between rails need to be electrically connected using a Weeb bonding strap. Preset the panel mounting hardware in the space in between the solar modules. Prior to placing the first module on the rack system, snap a chalk line for a straight edge of the lower section of the array. It is best to start at the bottom row using 2 people to hold the solar module while securing it top and bottom. Loosely tighten the module's mounting hardware on one corner and verify the module is square and/or parallel with the chalk line before tightening all mounting hardware. Making up the modules with the lead clips on the modules. Pre-wiring the modules for the string, keep in mind the positive or negative is traveling to the other end of the string through the modules. The next solar module will be carefully laid next to the first module and verified square using a torpedo level on the lower edge. Again, one installer will hold the module from above while the second installer tightens the module hardware. Simply repeat this process for the first row. Once the first row is set, verify all ends and mid-solar modules mounting hardware are tightened and the electrical series connection plugs between the solar modules and the home runs to the roof-mounted junction box have been made before proceeding to the next row. Before mounting the final solar module, ensure that series connections between the rows of modules are made and the final home run wire is brought down from the top row to the junction box. After all the modules are installed, visually inspect to make sure all electrical series and home run connections have been made correctly. For a typical 2.5 kilowatt system, a 2-pole 15 amp circuit breaker installed in the panel box serves as the AC disconnect in most building jurisdictions. DC voltage and polarity should be confirmed on the terminal block before commissioning the inverter. Refer to the installation manual for details. An additional number 8 system ground conductor must be added to the typical 240 volt AC system and must be bonded to the ground electrode conductor by means of an irreversible splice. Once the solar system install and safety checklist is completed and building department and utility approval is finalized and approved, the solar system may be turned on. Congratulations! The eSun Solar Array is now supplying clean, renewable electricity from the sun to your home or business. You have every right to be proud, for you are now part of the solution to preserving our planet's energy resources.